again I am back with another interesting video, and today I am going to discuss this Leetcode problem. Uh, yeah, this problem has been asked in, I guess, recent weekly contest. So without wasting much time, let's proceed to the problem. So in this problem, we are given a nums array and an integer k. We need to find a sub array of this array such that the absolute difference between k and the bitwise and of all the elements of that subarray is minimum. Basically, it's asking me to find this expression, the bitwise and of this interval L to R minus k, and I have to minimize this expression. So let's see what are the constraints for this problem. So n, let's say n is nums dot size of that given array. So constraint over n is up till 10 to the power 5, and values of this array are up till 10 to the power 9, and k is also up till 10 to the power 9. Okay, right. So let's try to solve this problem using brute force. In brute force, what we can do is, if this is our array, the vector, and we have to consider a sub array whose bitwise and when we take a absolute difference with k of that bitwise and of that particular subarray, it should be minimum, right? So for that, if I consider brute force approach, I have to explore all the subarrays, right? So for exploring all the subarrays, what I can do is, I can go to each index and explore all the subarrays starting from that index and update the answer value accordingly, right? So what I can do in brute force, explore all the subarrays starting from each index I. So for that, this can be the pseudocode for I going from 0 to n minus 1. For each value, I have initialized the AND value as this, but it is just basically all 31 0 to 2 to the power 31. All these 32 bits are set in this value so that I can update this AND value, right? So yeah, for each index, I am considering the subarray starting from that index and going till j. Basically, in that step, I am considering a subarray starting from index I and going till index j. And I am also calculating the AND value of this subarray by doing this step, right? And again, at every step, I am checking whether this answer value is updating or not. If you can easily see that this approach will give me time complexity of big of n square and space complexity of big of 1, because I'm not using any extra space over here, right? So yeah, the time complexity for this brute force approach is big of n square, whereas space complexity is big of 1 because I'm not using any extra space. If I see what is big of n square, in that in this case, in this problem, the constraint over n is up till 10 to the power 5. So big of n square will go up till 10 to the power 10, which will definitely give me TLE. So this approach, we can't use this approach for this particular problem. Let's try to optimize this. Basically, in this brute force approach, we are exploring all subarrays, right? Starting from each index. And we are calculating the AND value for that each interval separately. Let's try to optimize this thing. First, let's try to optimize the calculation of AND value of that particular subarray. In brute force approach, we are solving this particular subtask in big of r minus l plus 1 time complexity, because we are iterating from leftmost element to the rightmost element and we are calculating the AND value, right? If we can update, like if we can optimize this thing to big of 1 or something else, then we will we will be good to go, right? Because in that scenario, this big of n square will get converted to big of n, and n is up till 10 to the power 5, so this solution can be the valid solution. So let's try to optimize this thing. First, let's see what is this AND of L to R. This AND going from L to R is basically bitwise AND of all the elements starting from L index L going till index R, right? So how many elements are there in this interval? R minus L plus 1. Okay. So let's try to analyze the AND of subarray or AND of many integers using this small example. Let's take an example of these three numbers. Okay. So I have taken three numbers A, B, C. These can be any numbers. I am just these are as the numbers like the number present in the array is up till 10 to the power 9. That means they can have at most 32 bits, right? Because you all know that 2 to the power 32 is almost 10 to the power 9, right? That means we can have at most 32 bits. So let's try to analyze all the bits. So in this example, I have taken these three numbers which are having these bitwise binary representation. If I want to have the bitwise AND of all these numbers A, B, and C, then I can directly see uh, if a particular bit wants to be in the bitwise AND of all these numbers, that means that bit should be set. That is, that bit should be 1 in in binary representation of every number, right? You can see over here already also that this if I'm talking about this bit, this particular bit, this bit is set in A, it is set in B, but it's not set in C. That means that this bit can't be set in the AND value, right? Again, if I am talking about this bit, again this bit is not set in A, it's set in B and set in C, but it's not set in all these numbers. That means it can't be set in AND value. But if I talk about this and this particular bit, so both of these bits are having value 1, that is these are set in all these numbers. As these are set in all these numbers, that's why these are the only bits which are set in bitwise AND of all these numbers, right? Yeah, bitwise AND is correct. So the main key observation I can observe with this example by this example is if if a particular bit is set in all the numbers which I am considering, then only it will be the part of bitwise AND of all these numbers, right? Basically, if the number of times a bit is set in that particular interval or in the sample space is equal to the number of elements I am considering, then only it can be the set bit in AND value, right? So from this observation, I can see that if I am having the count of every bit which is set in all these numbers, so then I can do something, right? Again, if I read this statement again, if the number of times a bit is set is equals to the number of elements, then only this particular bit can be the part of our bitwise AND, right? So, yeah, let's take this example. I am having this array 1, 2, 4, and 5. Let's do indexing, right? Let's uh, let's see their binary representation. So 1 can be represented as 001, 2 can be represented as 010, 4 can be represented as 100, and 5 can be represented as 101. I'm considering only 3 bits here only because the other bits up till 32 bits, all these bit values are 0, so there's no need to represent these bits. So if I am having this type of array, right, and I have to find the basically the bitwise AND of particular subarray, I should have the count of every bit which is set at which index, right? So let's say I am storing this particular information in this 2D vector or 2D array, bits I comma j, where bits I comma j is representing whether the ith bit is set in jth in the element present at jth index of that vector or not. Basically, bits of I comma j is 1 if this particular bit I is set at index j or not. Otherwise, it's 0. It will be 0, right? So for that, I need to maintain a bits vector which whose size should be 32 cross n. This 32 is because I am having bits from 2 to the power 0 to up till 2 to the power 31, because I am having numbers up till 10 to the power 9 only, right? And this n is because of indexes. So let's try to do some kind of dry run for this example. I am having this array 1, 2, 4, 5. So I am having bits as rows and indexes as column. So I have stored. So here bits of 0 comma 0 will be if the zeroth bit is set at zeroth index of that element array. So the array is 1, 2, 4 and 5, and their bitwise representation is 0, 0, 1, 0, 1, 0, 1, 0, 0, and the bitwise representation of 5 is 1, 0, 1, right? So I'm talking about zeroth bit. So the zeroth bit is, let's check whether this zeroth bit is set at zeroth index or not. So the zeroth, so this is indexing. At zeroth index we are having 1, and this this particular bit wait a second, I'm talking about zeroth bit, and this zeroth bit is set at zeroth index, right? So 0 comma 0, it should be 1, not 0, right? Yeah. So let's now talk about this cell. This cell will store the information whether this zeroth bit is set at first index or not. So first index we are having 2, and zeroth bit is not set in 2, so it should be 0, right? So let's now talk about this cell 0 comma 2. So let's see whether this zeroth bit is set in second element at second index or not. So again, this is not set. I have corrected that mistake. So I was talking about this cell, right? Yeah, this cell. Whether zeroth bit is set in element at second index or not. So the element at second index is 4. Its bitwise representation is this. So zeroth bit is not set. So this value should be 0, right? And again, if I say about this cell, whether this zeroth bit is set at element present at index 3 or not. In like element present at index 3 is 5. So this bit is set in this element. So this should be 1. Similarly, I have basically calculated values for all these cells. I have evaluated this bits 32 cross n element. So now if I am considering this particular subarray going from index 1 till index 3, right? So for this subarray, if I am considering this particular bit, so the number of times this bit is occurring in this interval is only 1. This 1 is not equals to 3, the size of interval. That means that particular bit, zeroth bit, can't be set in the answer value, right? That's why I have taken this bit value as 0. Let's now consider this bit. So the number of times this bit is occurring in this interval is also 1, which is not equals to 3. That means this bit can also not be set. Basically, this bit value should also be 0 in the answer value. And again, let's see about what what's the behavior of this particular bit. So again, the count of this bit in this interval is also 2, which is not equals to 3. That means this bit can also uh, this bit is should also be having value 0 in the answer variable. That means by this logic, the end value of this particular subarray should be 0, comma 0, 0, 0, 0, 0, right? Let's verify this. So the values present at these indexes are, so a of 1 is a of 1 is 2, a of 2 is 4, b is 5, right? And these are just 0, 1, 0, 1, 0, 0, and 1, 0, 1, right? If I am considering their bitwise and, so the value will be 0, 1, 1, 1, 0, again 0, right? So you can verify this thing. This approach is working, right? So basically, for each bit, I need to calculate the particular count, the number of times this bit is said in the particular interval. So when we again we are having again a significant observation over here. Uh, yeah, we need the sum of if we need the sum of elements of this particular interval L to R. In that scenario, in general, we use prefix sum. If I maintain a if I can maintain a prefix sum for this, wait, yeah, if I can maintain a prefix sum for this particular bits vector, then I can calculate the count of particular bit in big of one time complexity, and I can calculate the AND value of that particular interval in big of 32, which is just big of 1. So let's discuss this approach also. If I am having if I am having a prefix sum vector, so for ith bit, I can find the count, the number of times it is occurring in that particular interval from index L to R by using this expression. How I can find this expression? Because if I am having a 1D array like this, and I am considering a prefix sum vector, one based indexing, so I am storing 0 value at 0th index, and at first index I am storing the cumulative sum up till 0th index, right? And at this index I am storing the cumulative sum up till this index. So yeah, at 0th index I am having 0, at first index I am having sum up till this 1, and at this index I am having sum up till this, which is 3, and at this index I am having sum up till this, which is 7, and at this index I am having sum up till this complete sum, this is 13, right? So if I am considering a subarray sum of subarray going from index 1 to 3, you can directly see that this sum is 2 plus 4 plus 6, which is 12. And if I am considering this sum using prefix sum, so the prefix value of index r plus 1 minus prefix value of index l, which is 13 minus 1, this is also giving me the same value. That means this pattern I can basically, this is a template, or you can see a formula by which you can calculate the sum of particular interval in big of one time complexity after doing some pre-computation for this prefix vector. So let's apply this technique to our problem. What I need to do in this problem is I need to find the minimum value of this expression, which is the bitwise AND of the subarray L to R minus K, right? I have to minimize this thing. So let's see. First of all, we all know that AND function is a decreasing function. How I know this? Let's take an example, any random example. Let's say I am having a array as 5, 4, 6, 2, 8, right? So the binary representation of 5 is 101, 4 is 100, 110, 2 is 010, and binary representation of 8 is 1000, right? If I am finding the cumulative AND the prefix and up till this value is 5, right? The prefix and up till this index is uh, 100, which is 4. Prefix and up till this index is again 4. And again, if I'm, yeah, considering prefix and up till this, it will be 0, 0. You can easily see that this is decreasing behavior, right? So I can say that AND value, the AND function, is a decreasing function. Whenever the number of elements for this particular AND operation increases, the AND value also decreases, right? So if I'm considering this particular subarray, like I'm having this array, right? So currently I am considering this particular subarray, right? L2R. I am having some particular AND value. Let's say I am having AND value as AND value, and I slides this particular R pointer to next pointer, right? I am considering this element also now. When so the R AND value will be updated as AND value and equals to nums of R, right? So after this operation, the AND value can't be increased. What we have to find is we have to find the closest value of this particular AND value, which is closest to K. So whenever I increases the subarray size, the AND value decreases, right? So if I am having initially this condition holding, that current AND value is, let's say, less than equals to K, right? So if I push this L pointer towards right, if I slide this window by decreasing the size of this window, then the AND value will increase and L value will go closer to K value, right? In that scenario, I can write this thing, right? While AND value is less than equals to K and L is less than R, just for uh, maintaining this behavior that L is less than equals to R. So yeah, what I can do is I can update the answer value as a minimum of that answer and that absolute difference between the AND value and K, and I can increment the L pointer, left pointer, right? So after this while loop, uh, the AND value is greater than equal to K, basically greater than K, right? So just after going from this while loop to this line, that means the AND value is greater than K, but it is closest to the K. So I can update this answer again at this step, right? Again answer and this absolute difference, because when I am at this step, my AND value is approaching K from left side, whereas when I am at this step, my K is here at lumber line and my AND value is somewhat at this point, right? And again, when I will consider more R's towards right, this AND value will decrease, so it will approach K from right side. So let's go to the coding part now. Yeah, so yeah, this was the function which I have to implement. I have been given a nums vector and an integer K. So let's store the size of nums inside this variable n. Let's just create the prefix vector for this particular like prefix of I comma j will store whether this ith bit, the number of times this ith bit is set up till this index j, right? And I am using one based indexing, so that I will tell you why I am using one based indexing. So let's now build the prefix array. So I is going from 0 to 32, which is bits, because my bits are going from 0 to 32 since my number is up till 10 to the power 9. If in case my number would be up till 10 to the power 18, then in that scenario I should use the number of bits up till 64, because 2 to the power 64 is up till 10 to the power 18, right? So in this step, I am considering one based indexing. J is going from 1 to n, and I am updating prefix value of I comma j as prefix value of I comma j minus 1 plus I am incrementing this thing if and only if this particular bit is set at this particular index, right? Okay. After building this prefix vector, I will store the final answer, minimum, basically the closest answer to k, right? Not closest answer to k, the minimum difference I can have between k and bitwise and of subarray, right? So I am using two pointer approach here, pointers, where the L pointer is marked like initially the L pointer is at 0 and R pointer is also at 0. R is incrementing one by one. So initially, if my AND vector, not if my AND value of the particular subarray L to R is less than equals to K and my L is less than R, so by incrementing L, I can increase the AND value. So in this scenario, my AND value is approaching K from left. So the difference is decreasing. That's why I'm updating this answer value as answer minimum of answer comma absolute value of this difference between the bitwise AND of that subarray and K. Here my here K is greater than equal to AND value. Basically my AND value is approaching K from left side. Yeah, and here the K my AND value is approaching from right, and I am returning answer. So let's copy the code and let's run the sample cases. Let's see whether these are running or not. Yeah, sample cases are accepted. Let's submit the code. It's getting accepted. So before ending this video, let's analyze the time complexity of this new algorithm. So in this new algorithm, what I am doing is I'm doing a two pointer. I'm using a two pointer approach where L is initially 0, R is also initially 0, but at each step my R is incrementing. So R value is going from 0 to n minus 1 only once, and L is also going from 0 to almost it, at worst case scenario it will go up till 10 to n minus 1. So it will take big O of 2 to the power n, and inside these loops, let's go the code again. Yeah, inside these loops I'm using this find and this find and is taking me big O of 32 time complexity. So overall I can say the time complexity for this code is 2n plus 32 plus 32, which is almost big O of 2n time complexity. And if this is time complexity, right? If I say what is space complexity for this problem, I'm using external space for storing the information about bits and indexing, for which I'm using this prefix vector of size 32 cross n. So the time space complexity will be 32 cross n only. Space complexity and time complexity are not giving me any kind of TLE or MLE. So this is a valid solution. Thanks for watching. Bye bye.